and not moving data around is the trick to the whole contribution. Hey guys, how's it going? Welcome back to another episode of Head Crashing Informatics. And I need to tell you, I'm totally excited because the OpenJDK team has accepted at least a part of my contribution that I am working on since, well, let's think about it, since April. And meanwhile, we have September. And it was a tough ride, and I will do a series of videos about this contribution, and this is the very first one. In this video I will show you everything that actually is merged in the OpenJDK mainstream branch and is planned to be in JDK 18. So what you see today will definitively be in JDK 18. So what is this all about? Let me show you a piece of source code. If you remember in one of my recent videos, which you will find here or here, I don't know, there I explained that when you are copying files from one stream to another stream, then you have different ways to do that. And we noticed that one of these ways, which should be one of the fastest actually, was the slowest. And we were wondering why that was, and I told you that it's caused by the original implementation in OpenJDK, which was assumed to offload to the operating system to do that copy, but actually did nothing in that way. It actually pulled all the file bytes from one file into the JVM memory, and from the JVM memory back in the other file. So we all know that copying bytes from the operating system into the JVM heap and from the JVM heap back into the operating system's memory is a rather slow process. So yes, it's not really dealing with single bytes, it's dealing with rather large buffers. But on the other hand, that buffer is not huge, and it's useless to copy it into the JVM's memory actually, because we don't want to modify it actually. It's a different thing if you have streams chained, then certainly you want computations with it, like buffering it or reversing it or compressing it or whatever. But in my special case, I just wanted to copy from one stream to another unchanged, which you need, for example, when you are doing Maven to download from a repository to your hard disk, or uploading from your hard disk to a repository. So you don't want to touch the bytes actually. And in that case, we want to have really an offloading to the operating system. And this was just not the case. Actually, everybody looking in the documentation in the Java doc thought it would be the case, but it isn't. Until JDK 18, because now I did exactly that. So let's jump right into the code and look what we have there. So what we got here is the source code of the InputStream class, and what we want to improve is the performance of the transferTo method. You can see that method here, and actually not only you would expect that it's rather convenient to actually move all bytes around with transferTo, you actually would think that it's also the fastest method, because the JDK can optimize everything, or let the operating system do that. And here you see the original source code. So what it does in detail is first it checks the input parameter because it wants to throw an exception in case this is null. And then you can see here a rather simple loop that does simply this read into a rather small byte array, which is just 8Ks. So the buffer is really small actually, given a rather large disk blocks we have today. So it just reads 8K in one turn into a byte array, which is the Java heap, then checks if it actually has read something, writes out the buffer right to the other stream, and then computes the number of bytes transferred, and then it starts from scratch with the next block. So this is what happens, and you can imagine that this will iterate a lot of times, and it will actually have to go through the barrier between the JVM and the operating system really often, particularly for large files. When you have huge files like a gigabyte or 2 gigs, then you go here for really huge number of passes through this border. So this actually is one of the slowest codes that you actually could write to really transfer the bytes. Sorry to say that, but whoever wrote this code, this is more or less the simplest implementation that you could do. It's neither the most clever one nor the fastest one. So this is the reason why this code is actually the slowest you can use to transfer all bytes from one stream to the other, while it has the potential to be the fastest one. So what can we do to improve this situation? My original contribution proposed 5 improvements actually, but this video will only cover the very first improvement, and this is the one that will approximately 99% of the improvement will provide, because everybody of you is doing a file-to-file copy. So we're not talking about copying bytes from a socket to a file or from a file to a socket. We're really talking about file-to-file in this video. In future, there will be more proposals that I will send to OpenJDK, which will cover these cases. But for now, this is file-to-file. So my first proposal improves file-to-file. And by the way, Oracle told me they measured it, and it was 5 times faster than the original code. And my measurements were 2 times, because I have a really fast machine and it's not that big improvement here. But most of you will be between 2 and 5 times. So what's the trick with files to files copy? Typically, since Java 7, you will use the channels or the files APIs to open file access. You would say, no, I'm not doing this. Yeah, I know you're still using file input stream, file output stream, but the trick is built into that also. Oracle nicely copied my algorithm, not in the improved way, but a good way. I might improve that in future. So they copied my algorithm mostly and improved file input stream and file output stream also. But you know from one of my older videos that the file streams, well, I won't say are obsolete, but typically since Java 7 you wouldn't use file input and file output streams. You would use the files API or the channels API to access files. So what happens here is, if you use the files API, let me go here, you typically would say you open a file, and from opening the file you will get a stream. So we have here new input stream from path and new output stream to a path. So this is what we all do or should do since Java 7. And this one simply calls a provider and asks the provider to perform the actual operation. And the provider under the hood actually is calling nothing else than this code. So you also could use the channels API, which is a bit more complex to do, but you could do it. So under the hood, this will happen actually. So it creates a channel input stream, and what I did here, it also creates a channel output stream. This class did not exist actually. I wrote that just for sake of my contribution. Here was an inline code that I simply moved out, and we will see in a few minutes what it does. So what I actually worked on was that when I have a channel input stream and on this one I call transferTo, which we see here, this did not exist. So what happened was that the original code was running, the input stream code, the slow code with a small buffer. And since I override this method in JDK 18, we will have this optimized code, and we will go into that code right after telling you what these two things do. The first thing is a channel input stream is nothing else but a wrapper around an NIO channel. So you have the NIO API since Java 1.4 for high-speed native access of I/O resources like files or sockets in a non-blocking way. And a channel is like a direct connection to the operating system's buffers. You could imagine like that. So the channel input stream wraps such a channel, which is this one, and when it reads and writes, it accesses data blocks, and data blocks are not copied into the Java heap. That's the interesting part. It just has a pointer to the operating system memory, so it never transfers data unless you want it, and this is the big trick. And also the channel output stream does the same trick. It wraps a channel to a target file or to a target socket in a non-blocking way, and it does not copy files or file contents into the Java memory. It just addresses the memory blocks in the operating system. It does not move the data around. And not moving data around is the trick to the whole contribution.